Welcome to the deep dive. Today, we're tackling something really fundamental. The psychology of problem solving affects everything, daily stuff to, well, huge challenges.
It really does. And you've sent over a great set of materials for this deep dive, articles, research papers, all looking at how our minds work when we hit a snag.
Yeah, so our mission today is to kind of pull out the key insights from all that, understand the psychology behind it, look at different approaches, and maybe help you boost your own skills a bit.
Sounds good.
So let's start right at the beginning. Psychologically speaking, what is problem solving?
Well, it's more than just, getting an answer. It's really that drive, that motivation to get to a goal when there's an obstacle in the way.
Okay.
It involves your thinking processes, obviously, but also your motivation, the environment. It's a whole package. And problems themselves exist on a huge spectrum.
Right, from simple things to incredibly complex ones.
Ex-
Okay, so this range, the sources talk quite a bit about well-defined versus ill-defined problems. What's the main difference there, and why does it matter?
Yeah, that's a crucial distinction. So well-defined problems.
Mhm.
They have really clear goals. You know what you need to achieve. The steps to get there, or at least the rules, are usually clear too. And you know when you've solved it. Think like a math equation or the Tower of Hanoi puzzle.
Got it. Clear start, clear rules, clear finish. So ill-defined problems are the opposite.
Pretty much. They're fuzzier. The goal might be vague. The possible paths aren't obvious. And even what counts as a good solution can be debatable.
Like designing a sustainable city, maybe, or fixing a big social issue.
Exactly, those kinds of things. They often need more abstract thinking, maybe some creativity, just to even frame the problem properly.
So the type of problem really changes how you need to approach it, doesn't it?
Absolutely. It dictates the strategies that might work, the cognitive resources you'll need, even how it feels emotionally.
How so?
Well, a well-defined problem might reduce the initial cognitive load because the rules are clear, but an ill-defined one can feel overwhelming right away, Lots of uncertainty.
And that's really useful for you listening, especially if you want to avoid feeling swamped. Knowing the type of problem helps set expectations and pick the right tools.
Precisely. It helps you manage that feeling of being overwhelmed.
Okay. So whether it's well-defined or ill-defined, is there a general process we go through? The sources mentioned a cycle.
Yeah, it's often described as a cycle, though it's not always neat steps. First is usually problem finding, just noticing there is a problem and starting to understand it.
Okay, identify it, then what?
Then problem shaping. You try to structure it, organize the information, make it more manageable in your mind.
Makes sense.
After that, you generate alternative strategies, brainstorming, thinking of different ways you could possibly solve it.
Then you try one out.
Right, that's the implementation phase. You pick a strategy and give it a go.
And finally.
Verification. Did it work? Did you actually solve the problem?
But you said it's a cycle, so you might go back.
Oh, definitely. Especially with complex or ill-defined problems. You might try something, realize it didn't work, or you learn something new, and then you cycle back to, say, reshaping your understanding or generating new strategies. It's often iterative.
Got it. Okay, that's the broad process. Now let's dig into some of the foundational theories. The Gestalt approach comes up early. What was their main idea?
Right. The Gestalt psychologists, they really focused on how we mentally represent the problem. Their big idea was that solving a problem often involves restructuring that mental representation.
Restructuring, like seeing it in a new way.
Exactly. It's about mentally rearranging the pieces until suddenly the solution becomes clear. They weren't so focused on step-by-step procedures.
And this is where that aha moment or insight comes from.
Precisely. They contrasted insight, that sudden flash of understanding, with what they called reproductive thinking, which is just applying old solutions you already know.
So insight is more like productive thinking, creating something new.
Yes, exactly. Generating a novel solution by seeing the problem differently.
So how you model the problem mentally is absolutely key for them.
It's central. Reanalyzing it, shifting your perspective, that's what unlocks the solution according to Gestalt theory.
Who are the key figures pushing this idea?
Well, Carl Duncker is famous for his work on functional fixedness.
The candle problem.
That's the one, where people struggle to see the matchbox as a potential shelf because they're fixed on its usual function-holding matches. It shows how our standard assumptions can block solutions. His X-ray problem highlighted similar issues.
Right, we get stuck in mental ruts.
We do. Then there was Max Wertheimer. He really emphasized that distinction between productive, insightful thinking and just reproductive habit. And the core Gestalt idea The whole is different from the sum of its parts. That applies to problem perception, too.
And Wolfgang Kohler, the chimps.
Yes. Kohler's experiments with chimpanzees were quite famous. He observed them seemingly having sudden insights on how to use tools, like sticks, to reach bananas that were out of reach. Not just random trial and error, but a sudden understanding.
It's fascinating that these ideas from, nearly a century ago are finding support in modern neuroscience.
It really is. Studies using things like fMRI or tracking pupil dilation, they're finding neural correlates for that moment of insight, that cognitive restructuring the Gestaltists talked about. It seems there's a real perceptual shift happening in the brain.
Okay, so that's the Gestalt view, restructuring and insight. Now let's shift to the information processing paradigm. This sounds more systematic, like computers.
That's a good way to put it. This approach gained traction later, heavily influenced by computer science. It views problem solving as a search process through something called a problem space.
Oh, problem space. What does that involve?
It's basically a map of the problem. It includes the initial state where you start, the goal state where you want to end up. And the operators, these are the legal moves or actions you can take to get from one state to another. Think of it like navigating a maze.
Right, the paths you can take.
Exactly. And finally, there are often path constraints, rules you have to follow, things you can't do.
And this led to models like the general problem solver, Newell and Simon.
Yes, the GPS. It was a landmark computer program designed to simulate human problem solving. It used heuristics, particularly a method called means-ends analysis.
Means-ends analysis. How does that work?
It's about constantly comparing your current state to the goal state, identifying the biggest difference, and then selecting an operator, a means that will reduce that difference. It often involves setting intermediate sub-goals.
So break the problem down and take steps to get closer to the final goal. Seems logical.
It is, and the framework was extended. Simon and Leah talked about dual space search. Sometimes you're not just searching for the solution steps, but also trying to figure out the rules of the game itself, learning the operators as you go.
And Hayes and Simon highlighted the very beginning of the process.
They did. They stressed how crucial that initial understanding process is. How you interpret the problem description sets up the entire problem space you'll be searching through.
You know, it sounds like even though Gestalt and information processing seem different, they both really emphasize the importance of how you first represent the problem.
That's a really key convergence, yes. Whether you call it restructuring a mental representation like the Gestaltists, or defining the initial state and operators for your search space like Newell and Simon, getting that initial understanding wrong really hampers things in both views. A flawed representation leads to flawed solving.
Okay, so we've looked at puzzles, maybe more structured things, but what about the real world? Problems there are often messy, changing. That's where complex problem solving, or CPS, comes in.
Exactly. CPS research acknowledged that many real-world problems are dynamic. They evolve over time. They're interconnected. Changing one thing affects others. And they're often opaque. You don't have all the information. Very different from a standard lab puzzle.
And Dietrich Derner was a big name here, using simulations.
Absolutely. Derner was a pioneer. He used complex computer simulations, like the famous Lohausen one, where people managed a small town, to see how people actually cope with these dynamic, interactive environments.
And what did he find? Where do we typically go wrong with complex problems?
His work showed some common pitfalls. People often ignore feedback delays. They don't see the consequences of their actions until much later. They struggle with exponential growth, things escalating faster than they expect. And they tend to think linearly, like A causes B, instead of seeing the interconnected network of causes and effects.
That sounds incredibly familiar for, lots of real-world issues. So what did the successful problem solvers in his simulations do differently?
Derner found they were better at several things: making multiple decisions concurrently, focusing on core underlying causes early on, testing their hypotheses more actively, not getting bogged down in minor details.
More strategic, it sounds like.
Yes, and more consistent in their decisions. Crucially, they engaged in more active self-reflection, monitoring their understanding and changing their hypotheses if needed.
So it really highlights the limits of just studying simple puzzles.
It does. Findings from well-defined problems don't always generalize well to the complexities of, say, managing an economy or dealing with climate change.
And it seems to bring us back to expertise and that idea of metacognition, thinking about your own thinking.
Definitely. Effective CPS requires both domain knowledge, understanding the system you're dealing with, and strong self-regulatory skills to manage the complexity and your own approach.
Okay, this is great context. Let's shift now to the practical side, the actual strategies we can use. The sources distinguish between algorithms and heuristics.
Right, a fundamental split. Algorithms are like recipes. They're step-by-step procedures, logical rules that guarantee a correct solution if you follow them precisely.
Like a math formula.
Exactly. Great for accuracy, but they can be slow, require a lot of effort, and importantly, for many problems, especially ill-defined ones, there just isn't an algorithm available.
So that's where heuristics come in.
Yes, heuristics are mental shortcuts, rules of thumb, educated guesses. They're much faster, more efficient, let us make judgments quickly, but there's no guarantee they're right.
Examples.
Oh, things like the availability heuristic judging likelihood based on how easily examples come to mind, or representativeness judging based on stereotypes, anchoring sticking too close to the first piece of information. They're useful, but can lead to biases.
So choosing between them is a kind of judgment call.
It is. It's a metacognitive decision. You weigh the need for accuracy, algorithm, against the need for speed or efficiency, heuristic, considering the cost of being wrong versus the cost of time and effort.
Okay, let's unpack some common strategies, starting with the most basic, trial and error.
Yep, just trying things out until something works, restarting your computer maybe.
Yeah.
Edison trying thousands of filaments for the light bulb. It works, but it can be incredibly inefficient if there are many possibilities.
Right. Then there's means-ends analysis and sub-goaling, which you mentioned earlier.
Yes, breaking the problem down. Figure out the end goal, see where you are now, identify the difference, and take steps means to reduce that difference. Often, this involves setting smaller intermediate goals, sub-goals. Very common, very powerful for structured tasks. Think Tower of Hanoi again, or writing a long paper.
Working backward sounds intriguing. Start from the end.
Exactly. If the goal state is very clear, but the starting options are many, sometimes it helps to work backward from the goal to figure out the necessary preceding steps. Planning event attendance, certain types of math proofs use this.
What about hill climbing, always moving toward the goal?
Kind of. You always choose the next step that seems to move you most directly towards the goal state, like climbing uphill.
But there is a catch.
There is. You can get stuck on a local maximum. You reach a peak, but it's not the highest peak overall. You've improved your situation, but can't see the better solution because all immediate steps lead downward.
Ah, okay. And analogical reasoning, using past problems.
A really powerful one. You notice a similarity between your current problem, the target, and a problem you've solved before, the source. You map the corresponding parts, and then you apply or adapt the old solution.
Like Dunker's radiation problem and the fortress story.
That's the classic example, showing how a seemingly unrelated story could provide the structural solution. We use this constantly, often unconsciously, drawing parallels between situations. Business decisions often rely heavily on analogies.
It seems like many of these involve either breaking things down or changing perspective.
That's a good summary. Breaking down complexity or finding a new angle, a new representation.
And then there are more explicitly creative techniques. Brainstorming.
Yeah, the classic group technique. Generate as many ideas as possible. Suspend judgment initially. Encourage wild ideas. Build on other suggestions. Quantity over quality at first. Lots of variations too, like brainwriting or mind mapping.
Lateral thinking, Edward de Bono's idea.
Right, that's about deliberately trying to break out of logical, vertical thinking patterns. Using provocation, random inputs, challenging assumptions to find completely different angles. Thinking sideways.
And finally, structural approaches like problem decomposition.
Divide and conquer, essentially. Break a huge problem into smaller, independent sub-problems. Solve those, then integrate the solutions. Foundational in things like project management or software engineering.
So a whole toolkit of strategies. But how does our brain actually deploy these? Let's talk cognitive architecture, starting with perception and mental representation again.
Sure, so it all starts with perception, right? Interpreting sensory input to even recognize there is a problem. Then we build that internal mental representation, our model of the situation, the goal, the constraints, the possible actions.
And we keep coming back to how crucial this representation is.
Because it is. It's influenced by our prior knowledge, our experiences. And as Gestalt showed, restructuring this representation can be the key to insight. Even how the problem is framed matters. Framing it as an opportunity might boost working memory, while framing it as a risk could impair it.
Interesting. Affordance detection. Seeing what the environment allows.
Yeah, perceiving the potential actions that objects or the environment offer, seeing a chair not just as something to sit on, but maybe something to stand on to reach something high. It all feeds into that initial representation, which relies heavily on attention and working memory. Get the representation wrong, and everything that follows is likely to be less effective.
Makes sense. So attention is the gateway.
You could put it that way. Attention lets us focus on relevant information, filter out distractions, hold key elements in mind while we work. Whether it's sustained focus for a long problem or selective focus to ignore noise or even divided attention for multitasking, it's fundamental.
And memory. Working memory and long-term memory.
Both are critical. Working memory is that mental juggling space, limited capacity, where we hold and manipulate information right now. Problem solving, reasoning, learning, they all happen here. There's a strong link between working memory capacity and problem-solving ability. Reducing the load on it often helps.
And long-term memory. Our knowledge base.
Absolutely essential. Long-term memory is the vast storehouse. Declarative memory gives us facts, concepts, past experiences, the context. Procedural memory holds the skills, the how-to knowledge for solving certain types of problems.
So it's about retrieving the right knowledge.
Exactly. Active, flexible retrieval is key. Experts are good at this. Their knowledge is highly organized, making retrieval faster and more efficient.
Okay, perception, attention, memory. What about reasoning?
Reasoning is how we use our knowledge to draw conclusions, make inferences. It's a core part of our executive functions. We use inductive reasoning bottom up, going from specific observations to broader generalizations, like forming a hypothesis.
And deductive.
Deductive reasoning is top down, applying general principles or rules to specific cases, like testing a hypothesis. Problem solving usually involves a constant back and forth between inductive and deductive thinking.
And overarching all of this seems to be metacognition.
Yes, metacognition, thinking about thinking. Our awareness and control over our own cognitive processes, it's strongly linked to better problem solving.
How does it help?
It involves planning your approach, monitoring your understanding as you go. Does this make sense? Am I stuck? And evaluating your strategy and solution. Did that actually work? Could I have done it better? It helps you choose the right strategies, recognize when you're blocked, and know when to change course. It's like the manager overseeing the whole operation.
So all these core processes, perception, attention, memory, reasoning, metacognition, they're all working together, interacting constantly.
Precisely. Along with other key cognitive processes like abstraction, analysis, synthesis, searching memory, learning from attempts, making decisions. It's a dynamic, iterative dance between all these components.
All right, so we understand the machinery, but we all know it doesn't always run smoothly. What are some of the biggest obstacles that get in our way?
Oh, there are plenty.
Yeah.
We've mentioned functional fixedness, getting stuck on an object's usual purpose, and mental set or Einstein sticking rigidly to a strategy that worked before, even when it's not suitable now. Like using a complex method when a simple one would do.
Those seem like failures of flexibility.
They are. Then you have broader cognitive biases. Confirmation bias, we love information that agrees with us and tend to ignore stuff that doesn't.
Yeah, that's a big one.
Huge. Anchoring bias, getting stuck on the first number or piece of info you hear. Hindsight bias, I knew it all along, after the fact. These distort our thinking.
What else trips us up?
Sometimes it's just irrelevant information embedded in the problem description that distracts you. Or we impose unnecessary constraints on ourselves, rules that aren't actually there, like in the classic 9-dot puzzle.
And in groups.
Groupthink can be a major problem. The pressure to conform, to maintain harmony, can shut down critical thinking and lead to really poor decisions.
Okay, so lots of potential roadblocks. But what about the flip side? What helps us succeed? What facilitates problem solving?
Well, expertise is a massive facilitator. Having deep, well-organized knowledge in a domain allows experts to see patterns, retrieve relevant info quickly, and often spend more time analyzing the problem up front. That comes from deliberate practice, usually.
Makes sense. And creativity, insight, incubation.
Absolutely key. Creativity is about generating novel and useful solutions. Insight is that sudden realization, often after hitting a wall. And incubation, stepping away from the problem, seems to help. Maybe your unconscious mind keeps working, or maybe it just lets a rigid mental set fade away.
Motivation seems huge, too. Believing you can do it.
Definitely. Self-efficacy, that belief in your own ability, is a powerful predictor of effort and persistence. If you think you can solve it, you're more likely to stick with it. Intrinsic interest, actually enjoying the challenge, also fuels effort. Goal orientation matters too.
And our emotions. We touched on this, but stress versus positive feelings.
A big modulator. High stress can narrow focus, impair working memory, make us fall back on habits, whereas positive effect is often linked to broader attention, more creativity, and more flexible thinking. Negative affect might make us more cautious, maybe too risk-averse. Emotional regulation is important.
Even personality and thinking styles play a role.
They seem to. Your preferred cognitive style, visual versus verbal, holistic versus analytic, might influence your strategy choice. And personality traits like conscientiousness and openness to experience generally correlate positively with problem-solving success, while neuroticism tends to correlate negatively.
What about the social environment? Working with others.
The social context matters a lot. Collaboration towards a shared goal can boost engagement. Group norms shape effort. Interestingly, having constructive dissenters can actually improve group problem solving. But the quality of interaction is key. Good discussion, debate, mutual support. Of course, poorly managed groups can hinder things too.
And again, framing comes back.
Yes, how the task is framed, opportunity or threat, influences how we approach it. And that initial problem representation is always there as a critical factor. It's all interconnected expertise can lead to mental set. Group cohesion can lead to groupthink. How we appraise the situation, cognitive appraisal seems to mediate much of this.
So knowing all this, how can we actively cultivate better problem-solving skills?
A big piece is developing critical thinking. That means actively analyzing information, questioning assumptions, evaluating evidence, considering different viewpoints before forming judgments or making decisions.
Oh, you teach that.
Things like cooperative learning, analyzing case studies, structured debates, reflective writing assignments, confronting ambiguous situations. These methods encourage those skills.
What about visual tools, mind mapping?
Mind mapping can be great. That visual layout helps organize ideas, see connections, and can spark creativity. Flowcharts are useful too, especially for mapping out processes or decision sequences in more structured problems.
Are there some general practical steps you recommend?
A solid general approach is, first, really recognize and define the problem. Decide consciously to tackle it. Spend time fully understanding it, maybe research is needed. Then, generate multiple options or solutions. Evaluate those alternatives systematically. Choose one and take action. Finally, evaluate the outcome. Was it successful? If not, what did you learn? Be ready to iterate.
And underlying this is developing that metacognitive awareness.
Exactly. These steps help you practice planning, monitoring, and evaluating your own thinking process. And of course, building foundational knowledge and staying motivated are crucial supports.
This field is clearly still evolving. What are some exciting current trends or future directions?
Oh, lots. Neuroscience is getting deeper, using brain imaging to see what happens during insight, how different brain networks contribute to reasoning or attention during problem solving. There's even work trying to link quantum mechanics principles to complex problem-solving models.
Wow. What else?
Computational modeling keeps advancing, creating more sophisticated AI models that simulate human problem solving, using things like neural networks. There's a big push to study problem solving in authentic, real-world contexts, moving beyond the lab to understand dynamic, ill-defined challenges, sometimes using VR or simulations. And the interaction between humans and AI in problem solving is a huge area. How do we collaborate effectively? So looking ahead,
We'll likely see more integration between neuroscience, cognitive psychology, AI, and maybe even ecological approaches. Continued focus on emotion, metacognition, incubation. Developing better theories and methods for studying complex, real-world problems is key. Ultimately, the goal is to understand how we can better foster the adaptive expertise needed to tackle major societal challenges.
Okay, so wrapping up this deep dive. It's clear problem solving is incredibly multifaceted, right? It involves our core thinking abilities, our feelings, our drive, the strategies we use. Absolutely. We've seen different theories giving us different lenses, Gestalt's insight, information processing search, CPS's focus on complexity, and we have this whole toolkit of strategies from logic to creativity.
And we know there are common obstacles, biases, mental sets, but also powerful facilitators like expertise, motivation, positive emotions, and good collaboration.
Exactly.
So, for you listening, hopefully exploring this psychology gives you a clearer picture of how we all navigate challenges, big and small.
Yeah, and maybe a few new ways to think about your own process. So here's a final thought. The next time you hit a problem, pause for a second. Think about these ideas. Are you stuck in a particular mental set? Could looking for an analogy help? How is the problem framed in your mind? Just reflecting on your own cognitive processes as you solve problems can be a really powerful step.